Good morning, everyone. Thank you for joining us today. On behalf of the Esco Group, I would like to welcome you to today's webinar. My name is Renee Tomlinson, and I'm the Executive Director of Esco Institute. I'm going to be handling the introduction portion of the webinar, and I'll be monitoring for any questions that may arise during the presentation. Jason Ojbroot from our development team will be presenting the remainder of the content on the Section 608, the core section. Just to go over what today's webinar format is, we are going to try very hard to end at the hour mark. Because the core section is the largest and contains the most content out of all the sections for preparing for the 608, there is a possibility we may cut over that hour mark. If you can stay with us and get through the whole thing, we certainly appreciate that. If you do have to leave after the hour, feel free to go ahead and you can submit questions during the presentation by using the question tool. If there's time at the end of the session, we're going to try and answer as many questions as possible. And just so you are aware, we are going to go ahead and record this webinar today. The recording will be available under the Proctor login area of the Esco Group website. So there is a new section under the instructor resources, the resource center, that is recorded webinars, and it will be posted there. Today is the second part of a 5-part series on preparing students to be successful for the EPA Section 608 certification exam. I have posted on the screen for you right now the future webinars. So basically they're happening every Wednesday of the month until the end of the month. So the next one next week will be for Type 1. The Type 2 will be on July 24th and Type 3 on July 31st. Please note that you do have to register for each one of the sessions if you do want to attend them. We will be recording all of them. But if you do want to attend them live, you do have to sign up for them separately. The material we're going to be going over in the webinar today is directly from the Section 608 preparatory manual that's published here by Esco Institute, and the PowerPoint as well. We have a newer version of the preparatory manual, the 9th edition, version 2. It is listed under the Proctor login area of the Esco Group website. So all the content that you will see gone over on this webinar today will be included in these PowerPoints and the prep manual. So certainly feel free to go and download a new version. And just as a reminder, the preparatory manual is only intended to be a guide for reviewing the materials for the Section 608 exam. It is not intended to be a formal refrigeration training course. Again, today's presentation is the second part of a 5-part series covering the EPA Section 608 Prep Manual and PowerPoint. Today we're going to be reviewing just the core section. Again, we're going to try and keep it to the hour, and so that we don't take up any more of the time needed to go over the content. I'm going to go ahead and hand the presentation over to Jason. Let me just go ahead and switch that over. Perfect.
Good morning, everyone. My name is Jason. I'm a content developer here at Esco. And today I'm going to walk you through the core section. We can see on screen here, these are the different areas that are used to generate questions for the exam. We're going to try and touch on as many of these as possible. As I go through this, if questions arise, please submit them in the question feature and we'll try to address them at the end. As we do go through the PowerPoint presentation, you'll see areas of the presentation that are highlighted in red. These should be focal points of the presentation that there are questions and or answers that are derived from this statement or this concept or this fact. So you'll see as we move forward, there are certain statements or facts that are highlighted in red. Pay particular attention to those. We're going to get started with a brief description of the ozone. The ozone layer is what protects the Earth from the sun's harmful ultraviolet rays. The image shown here is from 2004, and it shows the hole, which is centered mostly over Antarctica. The ozone layer is mainly located in the portion of the stratosphere, typically starting at about 7 miles up and extending to about 30 miles up. However, the height and the thickness can vary seasonally and geographically. Our biggest concern is the depletion of the ozone layer. Ozone depletion potential measures the ability of a substance to destroy stratospheric ozone. Scientific evidence points to chlorine in CFC and HCFC refrigerants as the primary cause of this depletion. The chlorine from CFCs and HCFCs will reach the stratosphere. It'll chemically react with an ozone molecule, which is O3, and break it down into chlorine monoxide, NO2. Chlorine monoxide will release the oxygen atom and continue to attack other ozone molecules, breaking them down. Due to its average lifespan of 120 years, a single chlorine molecule can destroy up to 100,000 ozone molecules. So how do we know that it's chlorine from refrigerants and not naturally occurring chlorine that's destroying the ozone? Naturally occurring chlorine will dissolve in water and rain out of the atmosphere. Chlorine from CFCs and HCFCs will neither dissolve in water nor break down into compounds that dissolve in water. As you can see, the slides highlighted in red there, so these are focal points for these particular slides. Another environmental concern is the global warming potential, or GWP. GWP was established to compare the global warming impacts of different gases over a period of time. Carbon dioxide, which is CO2, has a GWP of 1 and is used as a baseline gas for these comparisons. Most HFCs currently in use have extremely high GWPs, in the thousands. Hydrocarbons and hydrofluoroolefins, or HFOs, currently have the lowest GWPs. Refrigerant characteristics. ASHRAE Standard 34 groups refrigerants based on their flammability and their toxicity. Toxicity is represented by a letter, either A or B, and flammability is represented by a number, 1, 2, or 3. The 2 group has been divided into 2 more groups, the 2 and the 2L. The 2 has a low flammability, and 2Ls are slightly or mildly flammable. We're going to briefly go over the different types of refrigerants and some of their characteristics. CFCs contain chlorine, fluorine, and carbon and have the highest ozone depletion potential of the refrigerants being used. HCFCs contain hydrogen, chlorine, fluorine, and carbon. They have less chlorine and more hydrogen than CFCs, but still contribute to ozone depletion. HFCs contain hydrogen, fluorine, and carbon. They have an ozone depletion potential of 0. However, they typically have very high GWP, or global warming potential. Some examples of some of the refrigerants we just mentioned: CFCs are R11 and R12, HCFCs are R22, R123, and HFCs are R134A, R410A, R404A, and R407C. HFOs contain, just like HFCs, hydrogen, fluorine, and carbon. However, HFOs have at least one double bond between carbon atoms, which make them different from HFCs. They have a 0 ozone depletion potential and a very low global warming potential. Most HFOs are mildly flammable and as such are classified as A2Ls. They contain fluorine, making them less flammable than hydrocarbons. Currently, HFO 1234YF is being used in low-pressure chillers. Hydrocarbons contain hydrogen and carbon and are the least damaging of all refrigerants to the environment. They have an ozone depletion potential of 0 and a very low GWP, usually 10 or less. Isobutane, which is R600A, and propane, which is R290, are examples of hydrocarbons currently in use in HVACR equipment. Now, as a point of emphasis here, the propane that's used as a refrigerant is not the same propane that's used for the grill. It contains impurities, so the propane that is used as refrigerant, R290, has been cleaned, filtered, and made refrigerant grade quality. Azeotropic refrigerant blends contain 2 or more refrigerants that, when blended together, create a new refrigerant that behaves like a single component refrigerant. They're numbered in the 500 series. Zeotropic and near azeotropic refrigerant blends contain 2 or more refrigerants that have different boiling and condensing points. If they're 2-part, they're labeled as binary, 3-part labeled as ternary. They're numbered in the 400 series. Zeotropes and near azeotropes can fractionate or separate into their original refrigerant components. This can cause their composition to change when leaks are present. Zeotropes and near azeotropic refrigerant mixtures should be charged as a liquid to avoid fractionation. Temperature glide is a term used to describe when a blend has a range of boiling or condensing points rather than a single boiling or condensing point. Temperature glide can range from a few tenths of a degree up to 12 degrees or more. For example, R410A has a temperature glide of 0.3 degrees. So charging refrigerants that have temperature glide. This has been an issue for some technicians, some students to grasp. Instead of using a single temperature pressure chart, we have to use what are called bubble and dew points. Charging blended refrigerants that can fractionate and have temperature glide is done using these points, the bubble and the dew point. As an example here, we have a temperature pressure chart that shows 2 columns under 407C. The liquid phase is used for charging with subcooling, the bubble point, and the vapor phase is used for superheating, or the dew point. Bubble point is used when charging by condenser subcooling. Dew point is used for charging with superheat. For updated leak rate, service, and recovery levels, the EPA now uses 4 pressure ranges based on the refrigerant's liquid phase pressure at a condensing temperature of 104 degrees. These are the temperature classifications of the refrigerants. Previously, it used to just be low, high, and very high. They've added a medium class for refrigerants. So now we have low, medium, high, and very high pressure refrigerants. We've put a chart up here to show you the difference between how they're separated. Low pressure refrigerants at 104 degree condensing temperature have a liquid phase pressure of 30 psi or lower. Medium pressure are at 30 psi to 155 psi. High pressure are at 155 to 340, and very high are over 340. As an example, low pressure refrigerants would be CFC 11, HCFC 123, and HFO 1233ZD. Medium pressure refrigerants would be CFC 12, HFC 134A, HC 600, and HFOs 1234YF and 1234ZE. High pressure refrigerants would be HCFC 22, HCFC 404A, and HFC 410A. Very high pressure would be R744, which is CO2. We're going to move into refrigerant oils. HCFC blends use alkylbenzene oil, which is a synthetic oil. HFCs typically use polyester or POE oil, which is also a synthetic oil. POE oils shouldn't be mixed with any other oils. When performing a retrofit from an HCFC to an HFC blend, most manufacturers will recommend that the oil be changed to the POE oil. It should also be noted that POE oil is hygroscopic, which means it readily absorbs moisture. So it should be limited to exposure to the atmosphere to 15 minutes or less. We're now going to dive into the Montreal Protocol and the Clean Air Act and some of their regulations and requirements. The Montreal Protocol was a treaty signed by many nations that was meant to address ozone depleting substances, and the United States was a signatory to that. To stop the stratospheric ozone depletion, the United States has phased out or is in the process of phasing out CFCs and HCFCs. It is Section 608 of the Clean Air Act that establishes regulations for the HVACR industry. It is a Section 608 certification that a technician is required to have to purchase these regulated refrigerants. Distributors that sell regulated refrigerants must verify that anyone purchasing the refrigerant employs or possesses a 608 certification. Anyone performing an activity that violates the refrigerant circuit, and what that means is by accessing or opening the refrigerant circuit, is required to have a certification. A certification is not needed by persons that are servicing external components to the refrigerant circuit, such as electrical circuits. Listed in the Clean Air Act are a set of refrigerants that are exempt from the prohibition on venting, such as ammonia, CO2, and some of the naturals like R290, which is propane, or isobutane 600A. Also, when a small amount of refrigerant is used as a trace gas for leak detection, it also is exempt from the prohibition on venting. The EPA does not consider this a refrigerant when it is used as a trace gas, and by definition, it's a few ounces. As of 2017, the fine stands at $44,539 per day per violation for a violation of the Clean Air Act. If the EPA were to change regulations in the future after a technician were to become certified, it is the technician's responsibility to both learn and comply with any future changes. State and local governments may pass laws that are stricter than what the Clean Air Act calls for. In the United States, coming up in next year, 2020, our HCFC 22 and HCFC 142B will be phased out. The rest of the HFCs will be phased out in 2030. So supplies for those types of systems, the refrigerant in those systems, will come from recovery and reclamation efforts of technicians. It is not a violation to continue to service these systems. If a system runs on a refrigerant that has been phased out, as long as there's a supply of refrigerant in stock or a replacement refrigerant for that system, it is not a violation to service those systems. Refrigerant that has been returned to be reclaimed must meet AHRI standard 700 for purity before it can be resold. A refrigerant that has been recovered but not reclaimed can only be charged into the system from which it came or into a system with the same owner. Used refrigerant that does not meet AHRI standard 700 cannot change ownership without first being reclaimed. Recovery machines that are used to recover regulated refrigerants must meet EPA standards. AHRI standard 740 is the standard for recovery equipment testing. There is no requirement that a recovery machine must be able to handle one or more. It must only be able to handle one refrigerant. It can handle 1, 2, 3, 4. There's no requirement that it can handle more than one. Sealed systems, package systems that do not have service valves must be equipped with some sort of process stub or service aperture that's used to access the system using a piercing type valve. These piercing valves are temporary and should be removed and replaced with a permanent valve when any repairs are completed. When disposing of appliances with 5 to 50 pounds, the EPA does not require the technician to record the model and serial number. However, records must be kept indicating the type of refrigerant recovered, the quantity of refrigerant by type, the quantity recovered from appliances that were disposed of in each calendar month, and the quantity of refrigerant by type sent for reclamation and/or destruction. It's the EPA that can exempt refrigerants from venting, not companies or technicians. And they will determine which refrigerants don't have an environmental threat and list them under the exempt section of Section 608. So some of these exempt refrigerants are your natural CO2, some hydrocarbons such as 290 and 600A. It is still lawful to service existing R22 systems using the existing supplies of R22. It is not legal to top off R22 with another refrigerant, such as 410A or any of the EPA-approved replacements for R22. Topping off a refrigerant will cause mixed refrigerants, which may be impossible to reclaim and may cause damage to the system. Refrigerant cylinders are disposable cylinders. Before they are disposed of, the pressure should be reduced to 0 by recovering the refrigerant and then rendering the cylinder useless. There's a little knockout that's punched out, and typically AHRI recommends that you write empty on the cylinder. The metal should be recycled when applicable. It is the final person in the disposal chain that is responsible for ensuring that any regulated refrigerant has been removed from appliances before they are disposed of. A violation of the Clean Air Act would consist of a knowing release of any regulated refrigerant during the service, maintenance, repair, disposal of appliances. Added to that, we add vandalism and theft. Cutting the lines when the unit is stolen is a violation of the Clean Air Act. Refrigerants emitted when cutting a line without first recovering the refrigerant is a violation of the Clean Air Act, so the refrigerant must be recovered first. Venting refrigerant from a recovery cylinder or recovery machine is a violation. Records of recovered refrigerants must be kept to ensure that venting does not take place after recovery. As we said earlier, isobutane and propane are currently in use in many systems. They're used in household refrigerators and freezers. This refrigerant is exempt and can be vented. However, adding nitrogen to a fully charged system that uses a regulated refrigerant for the purpose of leak checking would be considered a violation of the prohibition on venting. We said earlier that a trace gas can be added to a system charged with nitrogen for the purposes of leak testing. A trace gas is only a few ounces of refrigerant, and that would typically be the refrigerant that is used in the system to prevent any contamination, cross-contamination, or mixing of refrigerants. We're going to go over the 3 R's. Recovery means to remove the refrigerant in whatever condition it is from the system and simply store it in a container. No further testing, anything is done. So the term recover means to remove the refrigerant from a system and store it into a tank. Remember that recovered refrigerant can only be charged back into the system from which it came or into a system with the same owner. If the refrigerant is not to be reused, it can be brought in to be either recycled or reclaimed, the other two R's. Recycle means to take the refrigerant and pass it through a recycling machine, which is a series of filter dryers and possibly some distillation, but it extracts some of the air from and impurities from the refrigerant. Now, it does not mean that the refrigerant has been brought back to AHRI 700 purity. Recycled refrigerant, just like recovered refrigerant, can only be used in the system from which it came or into a system with the same owner. Reclaiming is done at one of the facilities. It's when we bring the refrigerant tank in to a drop-off point, collection point, and it's sent to be filtered, distilled, everything brought back to AHRI 700 standards to be sold as new refrigerant. There is a chemical analysis that's performed on the refrigerant to ensure its purity. So the 3 R's: recover, recycle, reclaim. The two types of recovery processes we're going to discuss: system dependent or passive recovery, which is a non-pressurized container, and it captures refrigerant with the assistance of the compressor in the system or the pressure differential between the container and the system itself. It typically is not capable of capturing all of the refrigerant in the system. A self-contained or active recovery system is the standard recovery machine that has a compressor. It's capable of pulling all the refrigerant out of the system without any assistance from the system itself. So we have system dependent or passive, which is again an empty vessel, or a self-contained or active recovery machine, which is a machine that can draw out all the refrigerant on its own. Remember, it's important that we do not mix refrigerants. So when performing recovery, we don't put multiple refrigerants into a recovery tank. You can take R22 from one owner, R22 from another owner, mix them, it's the same refrigerant. You cannot take R22 from one system and R410 from another system and put them into the same tank. This mixture may be impossible to reclaim, and in most cases has to be destroyed, which is a very expensive process. It also depletes future supplies of these refrigerants. Future supplies of R22 will come from the recovery and reclamation efforts of technicians in the field. If the R22 is mixed with alternative replacement refrigerants or 410A, the mixture may be impossible to reclaim, and that R22 will not be put back into the supply chain. If we're dealing with a small leak, we can use an electronic or an ultrasonic leak detector. Remember to verify if the refrigerant is an HFC or an HFO, that the leak detector is capable of detecting those types of refrigerants. Older models used to pick up on the chlorine that was in the refrigerant, and these newer refrigerants do not have chlorine. So make sure that an electronic or ultrasonic leak detector is capable of picking up the refrigerant that is in the system. Another leak detection method is a standing pressure test using dry nitrogen. The system should be pressurized with dry nitrogen to the pressure listed on the data plate, and a trace gas can be used if the leak can't be found. And we can use the electronic leak detector to pick up that trace gas. Remember, a trace gas is not considered a refrigerant by EPA, so it doesn't constitute a violation of the Clean Air Act. It's just a few ounces added to a system that is charged with nitrogen for the purpose of leak detection. Remember that a trace gas should match the charge that's in the system already. So if it's an R410 system, we would use R410 as the trace gas. After we found the leak and the leak has been repaired, a new filter dryer should be installed and a standing pressure test done. Again, the maximum system pressure is going to vary from one system to the next depending on the manufacturer's recommendation. Once the leak test has been performed, we can evacuate. For systems that contain flammable refrigerants, A2Ls or A3s, hydrocarbons, and HFOs, the leak test should be done before evacuating to 500 microns or lower. If there is a leak and we pull a vacuum into a system that uses a flammable refrigerant, we will pull air into that system. HFO refrigerants do not contain odorants like natural gas, and odorants do not need to be added to these systems. Dehydration, also known as vacuuming a system. The reason for dehydrating a system is to remove water and water vapor. That's it. If moisture is allowed to remain in an operating refrigeration system, it can form hydrochloric or hydrofluoric acids. When performing an evacuation, the hoses that connect the system to the vacuum pump should be as short in length as possible and as large in diameter as possible. The micron gauge or whatever vacuum gauge is being used should be connected as far in the connection from the pump as possible. This doesn't mean distance-wise, 2 feet away, 3 feet away. This is in the manifold hose connections that you're using. It should be as close to the system as possible so that it can measure the vacuum coming from the system and not the exhaust from the vacuum pump. Once the vacuum has been finished, the system should be valved off and isolated from the vacuum pump and allowed a time to rise to make sure the vacuum is stable. It's called the decay test. We're going to cover some general service procedures and safety procedures that should be observed when working on any system, whether it be a type 1, type 2, or type 3. When working with nitrogen, it should always be charged into the system through a regulator to the pressure listed by the manufacturer on the data plate. A relief valve should be used downstream from the pressure regulator. If multiple relief valves are going to be used, they must be installed in parallel, not in series. If they are installed in series, if one fails, they both fail. So if you're going to use multiple pipe in multiple relief valves, they should be piped in parallel. When we're pressurizing a system for the purpose of leak detection, we should never use oxygen and or compressed air. Again, an inert gas like dry nitrogen should be used. Oil combined with oxygen under the heat of compression can cause an explosion. There's a chemical reaction that happens that causes the pressure to rise rapidly and the system may explode. When heating a refrigerant tank or a recovery cylinder to raise the pressure, it should be heated with warm water or a warming pad. A live flame or open steam should never be used to heat a cylinder. The cylinder may explode or the refrigerant may decompose to form phosgene or hydrazine gas. If the refrigerant in the system contained chlorine, it's possible for hydrochloric acid to form. If the refrigerant in the system had fluorine, hydrofluoric acid may be formed. When working with any material, any refrigerant, any oil, the safety data sheet should be reviewed by the technician for safety standards, compatibility with other materials, things like that. Some of the new HFO refrigerants are not compatible with the silicone or elastomer seals that are used in some of the systems, the seals and gaskets. So when a retrofit is performed and the system is converted to an HFO refrigerant, some of the gaskets and seals that are used throughout the system may have to be changed. That material could be found in the safety data sheets. Inhaling refrigerant vapors can cause heart irregularities or even unconsciousness. They should be used in a well-ventilated area. Refrigerant is heavier than air and can cause oxygen deprivation, which is suffocation. The safest refrigerants would be designated A1, but even A1s can cause suffocation. Something newer, when we're using a flammable refrigerant, an A2, A2L, or A3, the tubing, the process stub and tubings must have a red color marking. Areas of the process stub that are color-coded red, this red coloring must extend 1 inch in each direction from an area where a piercing valve may be used. So in systems that are using A2, A2L, A3 refrigerants, we'll notice red tubing. A recovery cylinder should never be filled to more than 80% of its weight, of its capacity by weight. Care must be used to prevent overfilling. So we should use a scale or a thermistor, some kind of a method used to shut the system down when we reach 80% capacity of the recovery tank. These tanks must be hydrostatically tested every 5 years. This is typically done by the reclaimer when they receive the tank, and they'll stamp into the side the date it was tested, and we have 5 years from that date. Again, we said refrigerant cylinders are disposable cylinders. They should never be reused for anything. When the cylinders are empty, their pressure should be reduced to 0 and the cylinder be rendered useless and then recycled or scrapped. For people involved in the shipping of refrigerants, each refrigerant cylinder should have a label or a tag to identify the type of refrigerant that is in the tank. This also allows a technician's company to determine the amount of refrigerant recovered for record-keeping purposes. Remember, we discussed earlier on the requirements for technicians or companies as far from systems with 5 to 50 pounds, what they're required to keep records of. At this time, we'll start to take any questions that may have come in. I know we skipped over some things, some of the smaller items that have remained unchanged since the beginning, but at this time, we will answer any questions that have come in.
Jason, excuse me, we did have one question that came in asking about if a school system or apartment complex personnel, can they use refrigerants that were recovered from one building to top off the unit of another building?
As long as it is the same owner, yes.
We did have another question since we brought up the change in the book edition for the preparatory manual, asking about if the ISBN number is going to change for bookstore purposes. So because it is a variation of the 9th edition, the ISBN number is not changing on the preparatory manual. The ISBN number will be the same. All right, Jason, do you have the screen? Otherwise, let me go ahead and show mine. I just want to, let me get this up there. If anybody has any questions, Jason's email as well as mine are listed up here on screen. We do want to let you know that all the completed presentations are going to be found under the Resource Center of the Proctor login area. If you go to that Resource Center, there is a new link and section, and we do have some more questions coming in while I'm talking here. All the completed presentations are going to be found in the Resource Center. There's a new section called Recorded Webinars. They will be posted there. The other thing you'll notice that is up on screen too is the schedule for the remaining sections of the presentations for Type 1, Type 2, and Type 3, which are going to be the upcoming Wednesdays of this month, same time. So there is another question. Let's see. Please clarify the info highlighted in red on the slides indicates info in test questions.
I would say that there is a question revolving around that information, either directly or indirectly, that concept or that statement. Yes, those are the focal points. And the rest of the information on the slide gives depth and definition to that statement. So if you see something in red, it's something you should focus on when training, yes.
So there is another question too. Which weight that is stamped on the tank do we go by? Do we use WC or TW?
The water capacity, WC. The TW is the tare weight, the weight of the tank itself. The water capacity is the capacity of the tank if it was filled with water completely. So what it can hold. And I'd like to point out that there are more slides in our presentation in the proctor area. There was over 100 slides, but we kind of condensed some of it down to the 70 some slides we saw today. So these slides can be kind of spread out so there's not so much information on one slide.
Yeah, keep in mind the intention of the presentation here was to go over the material, to show you the areas that you're going to concentrate on when doing your training. But the PowerPoints that are available for you to download and use for your own training are expanded. There's more slides available, so you can go a little bit more in depth with your students or your trainees. On some of the material and the concepts. So, all right, I do not see any more questions coming in our question panel here. So with that being said, we're going to go ahead and end our webinar for today. Once again, if you have any questions, please feel free to reach out to Jason or myself, or you can certainly email our customer service at escogroup.org. That's always available to you as well. Thank you once again for joining us. We hope to see you back next week. Thank you. Have a great day, everyone.